Hey guys, Pankaj here. Welcome back to my YouTube channel. In today's video, we are going to talk about sentence tokenization. What is stemming? What is lemmatization? Okay, so let me share my desktop. Okay, so if you remember, we talked about what are stop words and what is the impact of a stop word in the given sentence, right? So we did a lot of data cleaning and we removed a lot of stop words and we plotted before and after the plot, and we could see like easily whatever text or whatever word is coming very rarely, it is clearly shown. Okay, and today's video we will be seeing sentence tokenizer, sentence. Okay, word tokenization we have already seen, so we'll see sentence tokenizer, then we will see lemmatization and stemming. Okay, so we'll see the difference and how to do lemmatization and stemming, as well as what is the impact, okay, and why we supposed to do that. Okay guys, so as usual I'll be importing these library NLP and different functions of tokenization, stop words and different stemmer. So we have three kind of stemmer in NLTK: Porterstemmer, SnowBallstemmer and RegExstemmer. Okay, and for lemmatization we use WordNet Lemmatizer. So these are nothing but different name and basically different kind of algo developed by different person. That's why based on their name they have created the stemmer function. Okay, and I am creating PLT library as well as RegularExpression. In case required, we'll be using it. So let's load this text. So I think this text I have taken from Wiki. I've already shown in the first video about Albert Einstein. Let's print this. Okay, so we have two paragraphs only. And here I'm not doing any cleaning because we have already covered, right? We'll just go with the raw data. But as per process in the fundamental step, what I told, first we'll do the cleaning, then only you should go ahead with the other process. So cleaning part I'm skipping now. Okay, so let's see what is sentence tokenizer. So if you remember in previous video when we did word tokenization, so we were removing all the spaces, right? So basically a given sentence we were dividing into all the words. So list of words are nothing but word tokenization. Now let's say in one paragraph we have multiple sentences, right? So how do you identify multiple sentences? Because after each sentence you will have one period, right? Dot means in the end of that sentence. So if you split the whole paragraph with the help of dot, and all the list of sentences will be returned, okay, after the splitting. That is what is sentence tokenizer. And we do have predefined function also like sentence tokenize. Yeah, send tokenize, that is nothing but it will be doing the same. So I'll just show how to do that. So one is like we have this text, I'm just going to use inbuilt function, okay, or maybe I'll just give st, that is sentence tokenize. So send tokenize, and what sentence you want to tokenize? The text. Okay, and by default anyway we are going to work with English language, so we'll use English, and here we will put our text and let's print st. If you see here what is happening, it is giving the list of all the sentences. Okay, so one sentence and after that you'll find another comma. Yeah, this is one sentence, and after that this is another sentence, another comma, that will be end of second sentence, and so on. Okay, so this is what is done. In case you would like to do, now if you don't want to use your existing function, that is sentence tokenize, how will you do that? So let's say we have text dot split, and I'm going to split by using dot print st. Once again, exactly same result you are going to get. Okay, so just to prove it, I'll do one thing, I'll just print the list. So this length is 15, and let's print it here as well. 14. There could be some difference because of maybe one extra dot might have been used or somewhere, right? Let's say we have period, we have not yet cleaned the data, right? So that's why you see this kind of discrepancy, but 14, 15, it is more or less same. Okay, so don't worry. And I'm sure it would have come because of double dot. Okay, so extra dot would have taken, and that's why extra sentences are there in this particular thing. Okay, but this will be doing sentence tokenization more intelligently. Maybe in this function, they would have done some extra process also. Okay, maybe they were doing cleaning and all, and that's how we got 14. Okay, but let's not worry. But internally, this is what is being used for sentence tokenizer. Either you use predefined function or you can use using split. Okay, now let's see the next one. So that was another way to do sentence tokenization. Let me just mention it. Using split function. Okay, so let's see the next one. So if you guys remember when we were talking when we were talking about stop words, right? So what was happening? So let's say you got the raw text, right? And raw text we first converted to lower text, right? Lower form, or we did lowercase for all the given word, right? So what was happening? Let's say there is one word called IT. So I work for an IT company. So that is capital I and capital T, right? If you do lower, then what will happen? IT will become it, right? And it will be coming as a stop word. So when you do remove a stop word, it will also get truncated from the raw text. So what will happen? You may lose one data, which is very important, one particular word, which is very important. That in this case, it is nothing but IT. Okay, so in this case, what happened? We can prepare upfront a list of those words which may be converted in the form of stop word, like IT is one of them. Okay, then there could be some other word, let's say switching on and off, right? On, maybe it can be taken as a verb also, and if you make it lower, it will become on, right? So preposition, correct? Similarly for off, correct? So those kind of word we know, right? This we don't want to get it removed by using stop word. So what we do, we always add them after data cleaning and after removing all the word which is there in the stop word. Okay, so that those can be retained in the existing data. So how to add them? Basically, you don't have to worry about this, because let's say we have a list and all you can do a dot, and this is, let's say I'm getting clean data after removing stop words. Okay, so let's say this is what I got after removing clean word. This is just for example for you guys. Okay, so now I know it was there, on is there, off is there. So what I can do, a dot append on, a dot append of, a dot append IT. There could be so many words, right? And finally print a. Okay, so when you got those words removed, then better you add it back. So better you prepare a list of those words where this kind of accident happened, right? Accidentally it got removed. Okay, so this will help you to maintain the originality of those raw text. Okay guys, so let's talk about stemming. So what is stemming? Why this stemming word comes? So let's say you have one proper dictionary word, let's say play. Okay, you are going to play a game. So play will have multiple forms, right? Let's say play, then played, then playing, then plays, correct? Multiple words are there. And in machine learning, when you go for text processing, right? So each word will be considered as a separate feature. Remember that. I am going to show this again when I talked about machine learning. So, but you, for timing, you just remember each word will be considered as a feature. So let's say you don't do data cleaning, and in the word you have a lot of words where multiple forms of same root word have been used. So one example is play. So you have play as well as you have playing, plays, played. Okay. So all those words will be considered as a separate word. Okay, so separate word means separate feature. So why to increase complexity of the feature when you have root word as the same? So 5-6 different type of words are there which belongs to same single root word. Okay, in this case, let's say play. So when you talk about feature reduction or the reduce the complexity of number of features, we always go with the stemming and lemmatization. Okay, so this was the main purpose of having stemming and lemmatization. So let me show the example now. So we have, let's say, I'll take some example. Let's say give given. Assume that I did some cleaning and finally I got all the word tokenized. Okay, in that word tokenized, these are the words I have. Just for example, give, given, giving, gives. What else we can have? Give. Okay. Print A. So now for stemming, we have three kind of stemming: Porterstemmer, SnowBallstemmer, and RegExstemmer. Okay, more or less they are doing the same, but there are big drawback about the stemming. So what it does, let me talk about drawback first. What it does basically. So when you do stemming, right, most of the cases or some of the cases, what happens? It doesn't maintain the root word of the or dictionary root word. Okay, so let's say if I give, give, given, giving, gives, gave, right? So finally, if you do stemming, right, there could be some chances like gives have been, you know, resulted as a GIV, just give. Giving has been resulting as GIVIN. So what happened most of the time, it just truncate the last one or two character of the word. So due to this, what happened, most of the word, whatever resultant word we are getting, it doesn't really looks like, it doesn't really look like a root word of the dictionary. Okay, so that is the main problem of the stemming, and this problem has been solved in lemmatization. Okay, it has a lot of like very intelligent algorithm written which will just do proper stemming. So let's take an example here. So Porter, I'll create an object Porterstemmer, TERST. Let me check in the library what is there. This capital, right? What I'll do, I'll just take all capital. Okay, then Snowballstemmer, then RegExstemmer equal to RS. Okay, so Porterstemmer, it will be just this. Let me pass this later. Okay, so now Porterstemmer has been created. Now once it is created, you just pass ps dot stem. Okay, so for stemming, what, let's say I just gave an example here, caught. Okay, so if you see caught here, right, it is not able to stem it properly, though its root word is what? Catch, caught, right? So this is the problem. Sometimes it will remove very well, but sometimes it is not able to remove it. Okay, so let's say you have give. For give also it is not able to do that. Let me see if I'm able to do it correctly. Stem word, okay. Given, okay. Gives, okay, for gives only it is able to do that. Fine, so let me run a for loop here for w in, what is the list? A, I'll just give words. Okay, for w in words, print ps dot stem, and I'll pass that word. Okay, so let's see what it does. And here, original word. Okay, so for give it has give, given, give, given, giving also got converted to give. Gives also converted to give, which is good. But for gave, you see, gave root word is also give, but it is not able to convert it. Okay, so that is the problem. So at least you are able to understand, right, what I'm trying to say here. You have one word which needs to be considered as a single feature, but due to its lot of variants based on the sentence and other thing, right, 5 different feature have been generated, and it is going to add more complexity where you have more number of words of different variations, right? So better you do stemming or lemmatization, which is preferred one, and reduce the number of features to single one. Okay, So that is what is happening with Snowball, sorry, Porter. Now let's go with SnowBallstemmer. Okay, so here working principle is same. I think it needs one language. So a lot of languages there, right? So for Snowball, they will ask like what language you want to have. So I'll use English. So for W in words, print W and SP dot stem. Let's check W. See here, give okay, given also given, no improvement. Giving is fine, gives is gave is also gave. It is like more or less very similar example and very similar result also we got as well from Snowball as well as Porterstemmer. Okay, now let's talk about RegExstemmer. So regex, as the name suggests, you can put regular expression. So what is happening? Let's say you have a lot of word, right? We have giving, correct? Gives. So in most of the verb, they will be adding either ed or es or simple as or ing, right? So you know, like these kind of suffixes will be there almost most of the words, right? So you can just put those kind of regular expression as an argument, and you give like how many minimum length you want. If it is matching only those many length of character, then only you should apply the RegExstemmer on the given word. Okay, so let's say I have some word will have, let's say, ing, right? It is going to end, so I'll put dollar symbol. Okay, some will have ed, like played, PLAYED. Okay, similarly we have let's use dollar, then es dollar, then what else we have? We will have s and with this, correct? And here it will take minimum, right? So this minimum is nothing but like minimum how many data you want. A stemmer that uses regular expression to identify morphological affixes. Any substring that matches the regular expression will be removed. Okay, so I can use minimum, let's say any number, right? But let's say I have some word which is having 4 letters. Okay, now let's create it, and I'm going to use for W in words, print W, then RegulareExstemmer dot stem W. So given, giving, you see what is happening. ing has been removed. So good thing is at least it is able to remove ing, but what is happening? It has not maintained the root word of the give. Okay, that is GIVE, not without E. Correct. Similarly with GIVES also E has gone. So those looks okay, but as far as English root word is concerned, grammatically it is wrong. Okay. Similarly for give. So it is not, because we are putting regular expression, right? It is just going to truncate the last 1 or 2 letter of the word. So it is definitely, it is very much clear it is not going to maintain the dictionary root word of the given word. Okay, so these are the drawback, but at least you guys should know what is different kind of stemmer existing. It may be asked in interview. Okay, so to overcome from this kind of problem, we have something called lemmatization. Okay, lemmatization is also doing the same thing. It has very intelligent algorithm in the background running, which will truncate all the unnecessary word and maintain the same dictionary root word. Okay, so let's do that. So we have wordnet lemmatizer. Okay, and let me print W. Words, right? So what I will do here for W in words, print W, then lemmatizer dot lemmatize give W. Okay, for give it is give, given, Okay, so here one more catch is there. Okay, so whenever you lemmatize, good thing about this lematizer is it needs a part of speech. Okay, so why it is part of physics? This is very important. I'm going to talk in the next video. What is PUS? That is part of speech, whether it is belonging to noun, verb, adjective, adverb, conjunction, whatever. Correct. So if you provide, then it is going to work very effectively when you provide a PUS tag. Okay. So let's say I know give is nothing but a verb, right? So what I can do, let me go default. And now I'm going to provide POS belongs to verb. Just put V. Now you see the magic, the big difference. See, all the form of word has been maintained, the same root word, that is gives. And see, 1, 2, 3, 4, 5. 5 feature has been converted to one single feature, that is give. Now you will know, or you will realize now how useful is lemmatization. Whenever you have, let's say you are doing machine learning on complete very big text data, right? 1,000 words are there, and each 1,000 word will be having multiple different forms. So maybe it will go up to 1 lakh features. Okay, if you don't lemmatize or don't do data cleaning, you will have 1 lakh features, and you are going to add a lot of burden to the machine learning algorithm while doing the data processing. Okay, so to avoid heavy processing or to speed up the process, better do the data cleaning, remove all the stop words, do lemmatization, then you proceed further. Okay, so now you know better. So let's take some more example. So this time what I will do, words to equal to playing, play, plays, played. Okay, this should be good enough. Okay, so this is also related to verbs. So what I will do, words to word. Oh. Okay, so playing is a verb. Okay, let me see why it is not doing. For playing only, it has not taken. Why? Let's say w dot lower. Will be able to do. Okay, so here are definitely different context. Playing might be treated as a different word, and it is trying to maintain the root word uniformity. That's why it is not converting playing as play. So as I mentioned at the first step, we always lower the test case, not test case, basically all the text. Okay, so that uniformity is maintained. So the moment you got lower, you see here, all the word have been converted to single feature, that is play. Okay, so now you know what is stemming, what is lemmatization, and their important role in machine learning. Okay, I'll be talking about this little more when I talk about uh, some case study on the text data. Okay, or machine learning algorithm which is specifically available for text processing. Okay, so I think similar kind of example will be repeated, but you will have much more clarity. Okay guys, so that's all about this video. I hope you liked it. Thank you so much. Bye bye.